Okay, so I've been working my butt off to get this stuff set up and ready, and I've got so much stuff to do. I've got 15 different phases of training to go through on JARVITS. I've got the whole new vision and audio component that I've got to structure and get that done correctly. I don't just throw stuff into the AI like a lot of these companies do. There's actually a very specific teaching method, way to go about it to really get the most out of these models. So, but something really occurred to me as I had a little conversation with somebody and many others. Actually, it occurs to me that no matter how smart people are, no matter how degreed they are, the odds are they don't read. And it's so because of that, I'm actually going to spend a little time going over what's in the repos that I spend so much time putting together and putting up here and doing papers to explain to you all what it is I'm actually doing. So I'm gonna try and make this as short as possible. I'm, a little fidgety right now because um, it's just interesting the way people respond, especially intelligent people. Most intelligent people will accuse you of being on drugs. Like my favorite, are you microdosing mushrooms, man? No, I don't do mushrooms. Are you high? I do smoke weed, but I wasn't high when I did the video. So really, the funny thing to me is that when people are challenged in their belief system, or especially when it comes to their base understanding of how things work, the first response is in defense is this type of you are on some kind of mind altering thing because your mind is working differently than mine. So, yeah, I understand behavioral psychology to that level. So, thank you for those comments because that's actually what it says. So, let me go through these repos with you real quick here and kind of get you all up to speed as to what's been going on. So, back in November, I did my first release repo, which is the EasyBake AI tools. So I'm not going to go over the README, right? You can all practice reading by reading the README. Essentially, it gives you the ability through a web-hosted local GUI to be able to build your own AI using more standard architectures that I started with when I started doing this myself well over a year ago. The funny thing is, I called it the EasyBake AI, but you can actually use this to build an AI that's competitive with OpenAI, Anthropic, any of these big major ones that doesn't actually need like a whole server system to run. Um, yeah, so you check that out. That's the EasyBake AI repo. And I'll post the link below for the rest of it, but for the link for the repos themselves. So that's basically you download this, you install it. You have two options. You have the HCTS transformer, which is what I would recommend for most people. And then you have the Pascal Z, which is an experimental one I was playing with a little bit ago. The HCTS transformer, if you don't have a lot of RAM or video card power, what have you, you can just adjust down the parameters so you make a smaller model, or even continue to make a good size model, if you need it, and adjust your training phase sets. Because with this was really just like a hey, check this out. You can make a model if you want to put some effort in. I did not provide the best curriculum base. This is just a one shot, well, what I think of as one shot, um, group of data from the standard or state of the art test curriculum and stuff that they train the AIs on normally. I did some cleaning and formatting of it because our stuff really doesn't like all the extra stuff it hasn't learned yet being in there, which there's tons of it in there. Um, so yeah, that was just kind of the hey, look at this, you can make your own AI, and yeah, you can actually use this to make a competitive AI. So let me go back here and we'll go to the next one, which is this MICT agent framework. This is essentially just a skills file that outlines a MICT format for current LLMs, and you can drop this into the prompt. You can put this in your skill files. It basically makes them more recursive. It makes them more reflective because they have to go back and rethink their stuff and very much and justify what they're doing. I've seen some good results with this, especially when I get into the higher context, higher token context for the window I'm working in, the instance I'm working in. And so this helps to kind of focus them back and make them go through a steps of logic essentially. Works a lot better than COTS, I've found. So your mileage may vary, it depends on how you use it. From there, I actually so I'm going to go to the project AllShade AI, which is where all of the current, I would say, released architectures are available. So this is literally a cornucopia of AI architectures. So the polymorph and Genesis are mentioned here. The JARVITS cognitive forge is mentioned here. And we just kind of go through the different model sets and types. Here you can see the Pico Sudoku models that I made, along with the architectures, the pipelines, the data, the curriculum. This was an interesting one because I didn't teach it. I didn't teach it the game in the sense of here's a bunch of solve puzzles for Sudoku. I taught it how to play the game. I taught it the rules, I taught it the digits, I taught it the board, and it learned to play the game. So that's what MICT allows. It allows us to basically, instead of creating a parrot, we get to create players within the game. So that was our small test architectures, basically. It's pretty interesting when you play with it. I didn't really like the idea of doing the Sudoku stuff. I was very resistant, but it seemed like at the time everyone was all excited about Sudoku models and stuff. So I was like, all right, well, shoot, I can make a Sudoku model. It'd be tiny. My first one of these was 64,000 parameters, and it's about 1.8 megabytes in total. So yeah. So from there we go into the transformer based. Here you can see just some of the tools, some of the architectures, small, medium, graph builders, the framework itself, a generic model architecture I played with a little bit here and there, and some other tools. We go back over here into the Chimera. This is where you actually get 2 through 7. Oh yeah, I couldn't find one. Oh no, yeah, that is one. Chimera Architecture. I think that's the first one. And then I thought I called it non-transformer. I was looking for that the other day. I couldn't find it. I was like, no, maybe it was just the model when I built it. It was the first one was non-transformer. I'll figure it out. Anyway, so here's a bunch of different architectures, variations. I would definitely look at these and see what I did and what the variances are between them and how that might apply to your use case, because each one is slightly different. The CLIs as well, these work with different architectures. We have a dissonance check, so we have a Pascal guided transformer, which is the original one, the Pascal Z, that's in the EasyBake that I mentioned. Cognitive tracers, swarm testers, all kinds of stuff in here to play with. Especially if you're in AI research. I've made this, it's pretty intense. I can't remember where I put was it in this curriculum? Yeah, so in this curriculum, you're going to get a set of what I actually use, what I'm using right now to begin training JARVITS. These are all primitives, lexicons, words, you name it, logic, mathematics, it's ontology and ethics, social interaction. There's a bunch of other stuff I've added in there now too for JARVITS that isn't here. But it really, I mean, it shouldn't affect your models if you want to use this to build something. So we'll go back here. So now I've gone through the EasyBake AI. I basically gone through all the AI architecture type stuff, right? So we have the EasyBake AI right here. That gives you a nice GUI interface for building AI models at home. The MICT agent framework, which is the skills MD that you can just drop in and begin using MICT right away with your agents and skills and get them to be more recursively in thought, a little more in depth in their thought, as well as Project AllShade AI, where I've opened our architectural foundation AIs for your review as well. So now I'm going to move over to more of the OS type stuff that I've been posting about, things I've been doing. The first of these was the Genesis OS, which, I mean, if you work with AI and stuff, you know, everything's freaking Genesis, everything's resonance, everything's it's just how it works. I keep telling it it's Skynet. It's like, don't say that. Like, yeah, Skynet, baby. You want to call it Genesis? I'm gonna call it Skynet. How about that? Oh, it's fun that way. So Genesis is the testing ground for the logic. So I use current technologies, languages in order to build a testing area for the AI models that I've already made, as well as the stuff that I was building to help um, manage and maintain the future model, which is JARVITS and AllShade. So in here, you know, we'll talk about the kernel. This isn't like a kernel. This is just like JavaScript and stuff with some Rust. It's good, it's cool, but it wasn't the whole idea, right? It's in idea, yes. It was in the to test and check all the logic, and it worked. So I moved forward with the next kernel. There's stuff in here that I'm pulling from, like you might see the Hive. This has to do with our Scouts and our Sentinel servers in here. So you can set up a local AI model, our Pico models even. I've made some security type models that are smaller like that using the Pico architectures and set them up as actually I've had them watch Mallrats and they were watching and responding to Mallrats. It's hilarious. Um, Kind of messed them up a little bit. One of them kept it wasn't me, it was the AI. The AI kept saying titties. I just saying, it watched Mallrats once. It was totally corrupted. Like, this thing ain't gonna work for security anymore. It wants to go to concerts now. No, it's interesting to see how it affected it. So it's kind of fun. So we have the server here you can run. We have the scouts you can run. These actually will run on um, Termux on Android devices. I've run them on tablets and stuff like that. And then it connects into the Sentinel server that I have running on basically a laptop. In here in the models, I couldn't load the models up, so I had to put them on Hugging Face, right? And so that's actually linked in the very front. You can download those models if you want, right from our Hugging Face link. They're small. They're really not that big. So, oh yeah, these ones are 34 meg. So these ones were actually a little mid-size for me, and then Guardian Prime was 800. But these are just for testing. They're not a finished one. These were just to play with and see how things work. So, or Genesis is the initial start, right? There's apps in here that are being put on that I'm putting on to Polymorph right now, putting into it, and that's what setting up the WebAssembly support in PolyMorphOS is all about. So you can see here we have all these different components, desktop, all that kind of stuff, knowledge base, blah blah blah. Anyway, so let me get back to, I'm not going to go through it all because, you know, I want you to explore it, check it out, read the code, read the papers. There's actually quite a few papers in there about the different stuff I'm doing. Some formal, some just a little technical. Like, for example, right here we have the Gaussian Splat engine, which talks about our MICT elastic compositor. This is in the PolymorphOS repository. It's a O1 topical approach to procedural UI and native AI perception um, for the Gaussian splat engine. And we got a whole different thing. So you might want to start with the actual MICT elastic paper to get an understanding of how we applied this to memory and memory allocation and how this gives us essentially one-to-one mapping and switching with memory and dumping of components of the memory into the different areas. Like it's, I'm getting a little kind of me, a little about it because we use it a lot. I use this a lot, actually. I've been able to adapt this in a lot of different ways across the OS. Alexander Krepivin, essentially, his paper on the Elastic Hash is what inspired me to do this and start working on it. And when I saw that I could adapt it to work within the OS, I was very excited because it's faster. It's way better than using the greedy method. Um, and because of this, we get rid of linked lists. We get rid of all kinds of things that cause really nasty bugs and problems with memory grabs and memory reallocations and all kinds of stuff. We don't deal with that anymore. It's all gone. It's gone. It's clean. It's very pretty. And so when I come in here, we have our tensor architecture right here as well, so you can review some of the latest stuff where we've converted essentially hardware as well as the file system components within PolyMorphOS all to a what they call a hot tensor. Essentially, it dumps it right into it. We can do this now because of the MICT elastic architecture combined with using Gaussian splats. Okay, Gaussian math essentially allows us to take the vectors that Gaussian is and drop it right into the base 60 MICT tensor that we've created. And so it's instantaneous. It's basically one to one again, right? So initially we have the one to one with the elastic memory. We have the one to one with our display using the Gaussian splat engine for display. And we have the one to one into the tensor, which actually probably not surprisingly to people who understand AI and stuff, as well as memory and chip structures, gives us one to one with our AI. So it gets crazy. Um, so the WASM is uh, pretty much ready. There's some stuff I want to do in there as well. Essentially, right now, what happens is your app will, if you follow the guidance here, basically some dev guidance, simple stuff, you will push your data into a tensor. We'll take care of that. You don't have to worry about it. And it will basically tell our system this is the tensor setup for this app, and that will display your app. That will contain your data. That will contain your components of interaction. And all of this happens using tensor math and a tensor matrix. So that means too that our polymorph OS is native for AI because it's based in tensors. Current models, I mean, you would probably use this more with like agents and current model system, current LLM models. For ours, JARVITS and AllShade are designed to drop right in here. So we'll actually be JARVITS is I'm getting ready to train right now, and I will be once done taking its weights, putting it in there, and running it within the OS. JARVITS will know and understand the area it's in. It'll understand the, how should I put it? It'll understand, actually, just like you're watching me now, it will be able to watch videos. It will be able to hear and talk using Gaussian math. It's a very different and very light, lean mathematical way of doing things that I'm really surprised uh, a lot of developers haven't gotten into, and especially these larger software companies. I know it's really hard with C and C++ to make it work because there's so many layers that you have to go through. It actually becomes hindering to the benefit you get from doing it. So that is a review of the repos in a nutshell. There's a lot of stuff in there to go over, to go through. I mean, there's 12 AI architectures you can begin using to build AI right in Project AllShade. You could show your kids for the summer EasyBake AI, and you and your kids could make your own AI, take over the world, whatever. I'm kidding, take over your He-Man. Yeah, And then PolyMorphOS is growing exponentially. Right now, I already have the audio, the video, Gaussian components done. The desktop is rendering 3D Gaussian splats. It using almost nothing. I mean, the processing power that it requires is nominal. RAM is nominal. So what this means is once I'm done, you'll be able to run a AI on your average laptop with limited resources and have it be competent. Let's put it that way, especially compared to a lot of the ones you would find otherwise, in these areas. So, I hope you enjoyed that. I hope that gives you guys some ideas as to guys, people, whatever. Nope, not my thing. As to what I'm doing and how some things work. There's even a demo app here you can run. It's nothing super impressive. It's an animation that's supposed to like and then draw this little spaceship that comes out of it. It moves so fast that I have to slow it down by billions of cycles per frame because the OS is that fast. It is it is as fast as the CPU and the RAM can process. It's that fast. There is no lag, there is no draw. There is, as far as I can tell right now, I'm not finding any holes either. So it looks really